Do you know how many electric machines are manufactured annually in the world? Any idea? Million, billion? About 14 billion electric machines are manufactured annually in the world, which means electric machines are everywhere, from energy production to oil and gas platforms and electric transportation systems. These electric machines are prone to various types of faults, from electric type of faults such as short circuit to mechanical like eccentricity, bearing fault, and so forth. Sometimes these faults can be very costly. For instance, in hydropower plant, unplanned stoppage due to the failure in a large one can cost up to 10 million NOK within 1 day. And for a two-space company, 1 day stoppage of the company, it can cost up to 10 to 11 million NOK. But sometimes it can be even worse. 1988, Piper Alpha, one of the world's largest oil and gas platforms in North Sea, 167 crew members lost their life due to the failure in the motor pump, and it cost 34 billion NOK for the company. 2015, in Netherlands, due to the failure in the generator, 2 young engineers lost their life, and it cost 75 million NOK for the company. For the past 10 years, I've been working on fault detection and condition monitoring of electrical machines. During this period, I wrote several papers. I wrote a book published by John Wiley in the US, and we believe we can provide a solution that can solve the industry's problem. The available solution for condition monitoring of electrical machines, they have a common problems. Either they're using offline methods, which they're very time consuming, and it's not a favorite of industry. And if they're using online methods, either they're using invasive sensor technologies that you need to stop the machine and put the sensor inside, which is a no-go for many companies. And for online solution, such as vibration monitoring, you need to have a very severe fault in order to detect the failure. And even if these methods can tell you there is something wrong in an electric machine, they will not tell you which kind of fault you have, where is the location of the fault, and what is the severity of the fault. So maintenance team can decide when to stop it. We are providing solution based on non-invasive sensor technology. We are measuring magnetic field outside the electric machine. We don't need to stop the electric machine. We can just simply go around and mount the sensor. All the data that the machine is monitored 24/7 are transmitted into a cloud where all of our advanced signal processing, pattern recognition algorithms reside in. And the output of this system is visualized either using AIMSES dashboard, or it can be integrated via API to third parties condition monitoring system. Our solution is not just AI. We don't feed raw data and hoping for some deviation in the data and raise the red flag that there is something wrong in an electric machine. We are doing feature engineering. We have a unique pattern for each type of fault. By using our method only for the hydropower plant, we can detect more than 10 different types of faults, from short circuit to misalignment to bearing defect and so forth. What we are doing, we are using pattern recognition. If the machine is operating in a healthy condition, what you will see is the top pattern, a uniform pattern. By having a short circuit in the rotor field winding, you will see this notch in the pattern. Regardless of the power rating, if the machine is very small or if it's very large one, like 100 to 200 megawatts, the pattern will be the same. If there is a bearing defect in the electric machine in the generator, then you will see this pattern. In case of having a static eccentricity, you know majority of Norwegian hydropower plants are located inside the mountain, and due to the rock mass movement, there is a static eccentricity fault. By using just 4 sensors, we were able to detect with very high accuracy the location and the severity of the fault. We did one measurement with Hofstrand Echo, and what we measured and calculated, it was around 14.8%. And the other consulting company, they did the same, and their results were 14.5. But the difference is, our method, it took only 1 hour, but for them it took 2 days to get the same result. And in case of having more than one type of fault, there is no go for available traditional methods to detect a fault. But we can even detect if there is more than 5 different types of fault at the same time in an electric machine, we can detect and discriminate each type of faults. By using AIMSES, as I said, we can significantly decrease the inspection time from days to few seconds, which means we can reduce the cost. And at the same time, thanks to high sensitivity of our system, we can prevent unexpected downtime for the companies. So far, our work has started from 2018. We invested up to 30 million NOK in the R&D activities. We have a strong IP. We have 1 granted patent, 1 in pending, and 2 DOFIs submitted. We had 7 successful tests with Statkraft and Hafslund Eco. And in summer this year, we had our first test with Aker BP in oil and gas engine. And we are working towards having first pilots with Seyra on Tunstad, Norway's largest hydropower plant. And there is a significant interest from different companies, including Rolls-Royce, Infineon, Framo, Kongsberg, in utilizing AIMSES. Here is the team behind AIMSES. The core team, we have a 50+ years of combined experience within condition monitoring and business development. And during this period, different companies from US and also Norway help us for hardware and software development. And final word, if you're interested, feel free to contact us for a pilot project. Thank you.